For any sequential system, you're going to need a clock. If we look at the pin planner, in fact, we find there's a clock already, clock 50. It's a 50 megahertz clock. So let's actually get that signal. So I'm going to move the LED now out of the way. And I'm going to rename this one clock 50. And it's important that it matches. Similarly, I could label this line. I could call it something else. I should just call it sys clock. So that means that I can avoid a rat's nest of wires by just relabeling a line, and it'll be implicitly connected. I'll show you what I mean. So I want to divide this clock, 50 megs, pretty fast. I want to get it down to something for demonstration purposes. Now we could write some VHDL to do clock division, but actually this FPGA has at least one phase locked loop, which is an analog or analog digital device with circuitry that can scale your clock in ways that would be very hard to achieve yourself. Now I believe there are 4 of those on the chip. I'm only going to use 1. So on the right hand side here you should have a panel called IP Catalog, and under Library, Basic Functions, Clocks, PLLs and Resets, there's this one here, the Altera phase lock loop. Double click that, and this is where we're going to put it. So I'm going to just call it clock divider, and make sure that VHDL is set. Now there's this wizard. So most things are the default answer. So what's the frequency of the clock input? You've got to change that to 50 megahertz. It's a grade 6 device that we're using. Click next. We should really do this, but I'm not going to today. The asynchronous reset, I'm going to deselect that just for simplicity, but I will have the locked output selected. This is a signal that goes high once the phase lock loop has locked and you're getting stable operation. Click next. Next again. I don't want in clock 1. I don't need any of this. Okay, so C0 is my output. So when it says C0 core external output clock, I'm going to put a desired clock frequency in. So I'm going to have in megahertz 0.01. That would be 10 kilohertz. If I try and go any lower than that, I don't think it likes it. No, it doesn't. Okay, so it's 10 kilohertz, duty cycle 50, everything else can stay the same. Right, click next. I don't want the C1 clock output, but I could have a different division, or C2, or C3, or C4, and I believe we are done. Click next. Now, I always have this one selected here, the VHDL component and the symbol file, the BSF there. So these two, the instantiation template file, I don't technically need. I'll select it for now, but because I might use it later. Okay, and we click finish. Now that can take a little while, but we should now have a component that we can place. So if I go to my symbol table and go to my project now, I've got my clock divider. Okay, I'm going to put it here. Draw a line. Right click. And again, I'm going to put sys clock, which is a 50 meg. And this one here, I'm going to go CLK 10K, should be a 10 kilohertz clock frequency. So we can see, looking at it, we've got a 1 divided by 5,000 ratio. So the input here and this one, I'm going to connect the LED to the locked signal. So once the face-up loop has locked, this light should come on. If it doesn't, you know you've got a startup problem. You need to change the properties of this or clean up your clock. And now we've got a 10 kilohertz clock, we can start doing some interesting experiments and bringing signals out onto pins on relatively low grade instrumentation. So if you've got a slow oscilloscope, for example, then these are signals that most devices can cope with.